Okay, today we're going to look at the steps for solving square root equations, and we're going to make a foldable. It's in a trifold, and on the outside of the foldable you're going to write the letters I, R, S, because those are going to represent the steps that we use for solving a square root equation. Alright, so we're going to go through the steps. As you lift the tab, underneath the tab you're going to write the steps, and then right below it you can mark one of the examples. Alright, step number 1. The I in IRS stands for isolate. We want to isolate the radical. That means I want to get the radical on one side of the equal sign by itself. Step number 2. We want to square both sides in order to remove the radical. And step number 3. We want to simplify and solve. And that's what the S stands for in IRS. And there's step 4, but it's not listed, and you know what step 4 is. We always want to check our solutions. So let's look at some examples. Example number 1, I have 48 equals the square root of 18d. Now this is a radical equation because your variable is underneath the radical. So step number 1 was to isolate the variable. Well, the variable is already isolated. We've isolated that radical sign. So step number 2 is to square both sides. So I'm going to square this side, and I'm going to square this side. And remember, when we square the radical, those cancel out. So I have 2,304 equals 18d. So now I have a simple linear equation that I need to solve. I'm going to divide both sides by 18. And I'm going to get d is equal to 128. So we've solved that equation. So now we're at the step where we want to check it. Now remember, to check, all we do is we take this value and we replace it into the variable. So I have 48 equals the square root of 18 times 128. 48 equals the square root of 2,304. Is the square root of 2,304 48? The answer is yes. Does 48 equal 48? That's a true statement, and therefore that's my solution. And remember, we're going to write our solutions in brackets. So I have 128 as my solution. Let's look at another example. Right on this one, notice the radical is not isolated. So in order to isolate the radical, I'm going to subtract 5 from both sides. So I have the square root of x minus 3 equals 4, because I subtracted 5 from both sides. Now I've got it isolated. The R says we're going to raise, so we're going to square both sides. And remember, when we square it, it just removes the radical. So I have x minus 3 equals 16. I'm going to move the 3 over, and when I move it over, it's adding the 3. So I have x equals 19. So it appears that my solution is 19. So now I'm going to step number 4, which means I'm going to check it. I go back to the original equation, and I'm going to put 19 in for x. So I have 5 plus the square root of x minus 3 equals 9. Notice I went back to my original equation. So 5 plus the square root of 16, or 19, minus 3 equals 9. So 5 plus the square root of 16 equals 9. And we know that the square root of 16 is 4, and is 5 plus 4 equal to 9? Yes, because 9 equals 9. I check it, it's true, and so my solution set is 19. And remember, we want to write our solution set in the brackets. Now, you may ask, why are we checking it? Remember in class we talked about extraneous solutions. These are the type of equations that if you don't check, you could get an extraneous solution. Let's look at one more example. Okay, my example says the square root of x plus 5 minus 3 equals x. Now this one's a little bit different. I've got an x underneath the radical. I've got an x on outside the radical. But I still do the same thing. I need to isolate the radical, IRS. So we're going to isolate the radical, which means I'm going to move the 3 over, so I'm adding 3. So I have the square root of x plus 5 equals x plus 3. All right, we're at step 2. It says we're going to square both sides because we're raising. So now I have x plus 5 equals, now remember when I square this, I have x plus 3 times x plus 3. So now we've got to go back and multiply those binomials. I have x plus 5 equals x squared plus 6x plus 9. So now you should look at this and think, oh, I've got a quadratic. So now I've got to solve using a quadratic. I've got to solve a quadratic equation, which means I need to move this over, set it equal to 0. We're going to move the 5 over, which means we're going to subtract 5. We're going to move the x over, which means we're going to subtract x. So I have x squared plus 5x plus 4 equals 0. You can use whatever method you want to use to solve this quadratic equation. I'm going to factor it because it's factorable. So I factored it. I set each factor equal to 0. X plus 4 equals 0. So x equals negative 4. X plus 1 equals 0. So x equals a negative 1. So my solution set appears to be negative 4 and negative 1. Now remember, I have to check them both. Okay, so I go back to the original equation in order to check it. So we're going to go back to the original, and I'm going to put negative 4 in for x. So I have the square root of negative 4 plus 5 minus 3 equals a negative 4. Well, negative 4 plus 5 is 1, so I have the square root of 1 minus 3 equals a negative 4. Square root of 1 is 1. 1 minus 3 equals a negative 4. Well, 1 minus 3 is negative 2, and negative 2 does not equal negative 4. So therefore, negative 4 is not a solution. Now we're going to check negative 1. So I have the square root of negative 1 plus 5 minus 3 equals negative 1. So I have the square root of 4 minus 3 equals a negative 1. I have 2 minus 3 equals a negative 1. So I have negative 1 equals a negative 1. That's a true statement. So my solution is only negative 1, not negative 4. Negative 4 is an extraneous, I'm going to spell that, extraneous solution. So it's not listed in my solution set. There's my solution set. So those are 3 examples on solving quadratic equations. Here are 3 more examples. You can solve those, and I will give you the answer to those in class. See you in class.